These are the notes on two forms for circles. We've already looked at these two forms in the previous notes for circles part 2. However, we now need to talk about what the two forms do for us. So here are the two forms. I'm calling the first form center radius form. However, the book refers to it as standard form. And then I'm referring to this as expanded form. There is an official name for that, but for our purposes, I think just calling it expanded form will make it a little easier. So it turns out that I can graph the equations of circles in this form. I can't easily graph them in this form. So what I have to be able to do is if I'm given them in expanded form, I need to transform them into center radius form. So this is very similar to when we had parabolas, and if they were written out, multiplied out, looked something like this, that I would complete the square in order to get them into the vertex form. In this case, I'm going to need to complete the square for both the x's and the y's. So let's look at an example. Very often when you're asked to rewrite the equation of a circle from expanded form, you're often asked, what's the center, what's the radius of the circle, graph the circle, and they probably won't even give you the hint that you need to complete the square. So the question will be, state the radius and the center, and you have to understand that that means that you need to complete the square here. So the first thing I'm going to do is I'm going to rewrite this so that my x terms and y terms are together. And I've moved over any of the constants, the numbers without variables, to the right-hand side, since I want my numbers that are constants on the right-hand side in the end, the r squared. I'm leaving a space in both of these spots because this is where I'm going to complete the square. And depending upon how your teacher taught you completing the square when you did parabolas, quadratic functions, you might have not seen exactly this, but whatever I add to this side of the equation, I am also going to add to this side. And same thing here, add something here, add it here. And I can do that. I can add the same number to both sides of the equation. I can subtract the same number. I can multiply the same number, divide the same number. So I'm not changing the equation. I'm just kind of changing the dressing on the equation. So remember, completing the square, we take our b term, we divide it by 2, and we square it. So that gets us 4 divided by 2, which is 16. So I add 16 here and 16 here. That's for the x's. Whoops. For the y's, I have a negative 2 as my b. I still divide that by 2 and square it. So that's negative 1 squared, which is positive 1. So I add 1 to both sides. I now can write this as a perfect square. I can factor it. So that's x plus 4 squared plus y minus 1 squared equals, and then I simplify this. The 1's cancel because one is positive, the other is negative, so I get equals 16. I now am in center radius form, or as the book calls it, standard form, which means I can write the center and I can write the radius. Which means I can now graph this. So remember, when we're graphing circles, the first thing we do is we graph our center. So negative 4, positive 1. And then I use my radius to go in the 4 cardinal directions, that many units. So I'm going to go right 4, left 4, up 4, down 4. So now I have 4 points that I can connect to make a circle. Please again remember that my ability to make circles is not perfect, and so my circles may end up being a little wonky, and yours will too. The most important part is that your teacher is going to really be looking for that the center is noted and that these 4 cardinal points are noted, and your circle goes through those 4 points to the best of your ability. Let's look at a second example. So I'm going to use the exact same process. I need to find the center and the radius and graph this, which means I need to complete the square. So I'm going to rewrite this so that my x's are together and leave a blank spot for the complete the square. My y's are together, leave a blank spot for completing the square. Move my 5 over to the right-hand side, and then I need a blank spot here for my completed the square x's and a blank spot for my completed the square y's. So completing the square, I take my -6 divided by 2 and square it, which means I add 9, and I do that to both sides of the equation. For my y's, I take my b, which is 12, divided by 2 and square it, which is 36. I add 36 to both sides of the equation. I now write my x's as a perfect square and my y's as a perfect square. And then I simplify my radius squared. And simplified, that equals 50. Now I can identify my center, which is 3, -6, and my radius, which is the square root of 50. Now I can simplify the square root of 50 in several different ways, but for the purposes, so the first way is to leave it as a square root. And you'll remember when you simplify square roots, you want to somehow rewrite this as as two numbers that multiply, where 1 is a perfect square. That turns out to be the square root of 25 times the square root of 2, which is 5√2. For the purposes of graphing, however, I need to actually be able to count, and so I'm going to have to get an approximate value. And so I plug 5 square root of 2 into my calculator, and I get the value of approximately 7.1. So, graphing this, I start by graphing my center over 3 down 6, and then I'm going to go in the cardinal direction, 7.1. So I've got 1, 2, 3, 4, 5, 6, 7, and a little tiny bit more. 6, 7, and a little tiny bit more. 3, 4, 5, 6, 7, and a little tiny bit more. 4, 5, 6, 7, and a little tiny bit more. Now this is where my circles look really wonky because the circles are getting bigger, and so my drawing ability kind of starts to fade. And so I'm gonna, oh boy. So that's a pretty wonky circle. So in order to help my teacher out here, I probably want to come over here and say that R is approximately 7.1. And then they can do a quick count there and they see that that's what it is. And, you know, we kind of forgive the inability to draw perfect circles.